we are given the following geometric series: 18, 6, 2, and so it continues. Now, because this is a geometric series, we know that it has a constant ratio. So 6 divided by 18 is a third. 2 divided by 6 is a third. So our constant ratio is a third. Now we want to calculate the sixth term in the series. In other words, we want to calculate T6. Now, because this is a geometric series, we are going to use the following general formula. There it is. The term in the unknown position is equal to A times R to the power of n minus 1. Now, in the place of this n as well as that n, we are going to put 6 because we want the sixth term. So T6 is equal to A, and now A is 18 because it's the first term. There it is. Times R, which is now a third because a third is our constant ratio. Now look at this. Because we have a third or a fraction for our constant ratio, we put it in brackets, okay? So that we know that this power, which is 6 minus 1, belongs to both the numerator and the denominator. So that's why we have it in brackets. Now this is quite easy, so to calculate T6, we simply type all of this into our calculator exactly as it is, and I can quickly show you. So what we do is we type in 18, we open up the brackets, press the fraction button, fill in the numerator, and scroll down, fill in the denominator, scroll to the right, close the brackets, then we press this exponent button, and then we just fill in 6 minus 1 and press equal. And there's the answer. There it is, and our answer is 2 over 27. So term 6 is equal to 2 over 27. And there it is, 2 over 27, which is basically our first term times 1, 2, 3, 4, 5 constant ratios gives us term 6. Now we are given the following question. Which term in the series is equal to 2 over 2187? Now in this geometric series, somewhere in the series we have a value of 2 over 2187, and we want to know which term it is. Now, because this is a geometric series, we make use of the following general formula. There it is. The term in the unknown position is equal to A times R to the power of n minus 1. Now we are going to do some substitution here. Because we know that the term's value is 2 over 2187, we put this into the place of Tn. There it is. Now that is equal to A, which is 18, our first term, there it is, times our constant ratio. Now our constant ratio is 6 divided by 18, which is a third. We can double check, so 2 divided by 6 is also a third, so the constant ratio is a third. And we put the third into the place of R. There it is. Now we would like to calculate n. Now let's see how we will go about doing that. Now this 18 is the coefficient of this base and the exponent. So we have to get rid of this coefficient first by dividing with it on the left side. So that gives us an answer of 1 over 19683, which is now equal to a third to the power of n minus 1. Now, because this is an equation that has exponents, we would like to make the bases the same. So we would want the 1 over 19683 to become a third. Now let's see how we will do that. So all that we do is we type in 19683, press equal, shift and fact, and there's the answer, 3 to the power of 9. So now we know that the 19683 is 3 to the power of 9. So we write it as 1 over 3 to the power of 9, and that is equal to a third to the power of n minus 1. Now another way that we can write this 1 over 3 to the power of 9 is by simply writing the third in brackets and then having this 9 on the outside. Now that's part of the rules of exponents, so if you're unsure, I recommend that you go back and just quickly go and check. So a third to the power of 9 is equal to a third to the power of n minus 1. Well, the bases are the same, so we can drop them. That means that 9 is equal to n minus 1. And finally, we move this constant, which is a minus 1, to this side. It becomes a plus 1, and 9 plus 1 is 10. So the 10th term is equal to 2 over 2187. So this is the first, the second, the third, the fourth, the fifth, the sixth, the seventh, the eighth, the ninth, the 10th. And the 10th term is 2 over 2187. And that's it. So I hope to see you again next time. Bye.